at the Khan tutorial.
Hey students, we want to solve this initial value problem, a nonlinear initial value problem, by the method of differential transform. So the first thing we're going to do is to transform each term of the differential equation. So we begin with a second order derivative, which is transformed as k plus 1, k plus 2, y k plus 2, and y squared is transformed as r from 0 to k, y of r, y of k minus r, and the trig function, which is sine. Suppose we have sine bx, where b is a constant. This is transformed as b raised to power k over k factorial. Then we have a sine k pi over 2. So these are the ways to transform the terms. Then for the initial conditions, we have y of 0 equal to 1, y prime of 0 equal to 0. So this one is transformed as this, y of k equal to 1, and then this is transformed as k plus 1, y k plus 1 equals to 0. So we complete the transformation at k equal to 0 only. So this becomes y of 0 equal to 1 and y of 1 equals to 0. So this is the transformed initial condition. Transform initial condition. So these transformed terms of the differential equation will be substituted into the differential equation as follows. So we have for the first time, first one, y prime prime, we substitute k plus 1, k plus 2, y into k plus 2 plus summation, that is the one for y squared, from 0 to k, y of r, y of k minus r, equal to sine. For our sine, the constant term here is 1. So it's going to be 1 over k factorial sine k pi over 2. So we begin to solve this at k equal to 0, k equal to 1, k equal to 2, and like that. So let's begin with when k is equal to 0. But before we do that, let us make y into k plus 2 the subject by moving all other terms to the right-hand side of the expression. So we have this way. So this one gives us a negative summation r from 0 to k, y of r, yk minus r plus one over k factorial sine k pi over 2, bracket closed. So when k is 0, from this summation, that means r will run from 0 to 0. So r2 will be 0. So substituting that into this expression, we're going to have y of 2 equal to 1 times 2 into negative brackets y of 0, y of 0 minus 0, which is 0, plus 1 over 0 factorial, which is 1, sine 0 multiplying pi over 2, bracket. So we also have bracket close here. So this gives 1 over 2 into negative our y of 0 from initial condition is 1, and then the other one is 1. So we have this plus 1. This is 1 times 0, because sine 0 is 0. Simplifying this, we have y of 2 equals to 1 over 2 multiplying negative 1, which is minus 1 over 2. So this is the result when our k is 0. K is 0, and then r is 0. So when k is equal to 1, when k is 1, don't forget that our r runs from 0 to k. So when k is 1 here now, r will be 0. There will be r equal to 0. There will be r equal to 1. So in that case, we have r equal to 0, 1. So having that in mind, and then substituting that into this expression that we have here now. So we are going to obtain y of 3 equal to 1 over 2 times 3 negative. So this time around, I'll first of all substitute the values of 0, value of r, which is 0 and 1. So y of 0, y of k minus 0. So when r is 0, plus y of 1 multiplying y of k minus 1. So that's that. Then plus 1 over 1 factorial, which is also 1, sine 1 times pi over 2, bracket closed. So we now begin to substitute the value of k inside the first bracket here. So that means I have y of 3 equals to 1 over 6 into negative y of 0, y of, so k is 1, that will be y of 1 plus y of 1 times y of 0, because that would be 1 minus 1, bracket closed, plus this is 1 times sine pi over 2. Then this gives us 1 over 6 into negative y of 0, as usual, from our initial conditions is 1, y of 1, 0, plus 0 times 1 plus 1 times 1. So simplifying that, y of 3 is going to give us 1 over 6. 1 over 6. So, and then let's go for one more term. When k is equal to 2. So when k is equal to 2 now, r will be 0, 1, 2. So let's quickly do that. So when k is 2, we are going to have y of 4 equal to 1 over 12 into, first substitute the value of r. When r is 0, k minus 0. When r is 1, k minus 1, plus when r is 2, k minus 2, then plus 1 over 2 factorial sine 2 pi over 2 bracket closed. So this will be 1 over 12 negative. So this will give us y of 0 here is 1 times here. This will be y of, our k here is 2. So that will be y of 2. And y of 2 from what we obtained previously was negative 1 over 2. So plus, then this one, y of 1 is 0 from the initial condition, multiplying y of 2 minus 1, which is y of 1, and y of 1 from the initial condition is 1, plus y of 2, which is 1 negative 1 over 2, here, negative 1 over 2 times negative 1 over 2 times y of 2 minus 2, which is 0. From the initial condition, that is 1. So that's that about this, plus 1 over 2 factorial is 2 times sine, which is 2, sine pi. Sine pi is 0. Sine pi is 0. So with that one, we have 1 over 12 into, so when we simplify everything that we have in the bracket, we are going to have 1 inside the bracket. So, and that will give us 1 over 12. So for y of 4, it is equal to 1 over 12. Now, collating all the terms, we do it this way. We say y of 0 plus y of 1 x plus y of 2 x squared plus y of 3 x raised over 3 plus y of 4 x raised over 4, and so on. So if we bring all that together, our y of 0 from initial condition is 1, plus y of 1 from initial condition is 0x, plus y of 2 from what you obtained previously is negative 1 over 2 x squared. Then y of 3 from our result, we got that as 1 over 6. So that will be plus 1 over 6 x raised to the power 3. Then finally, we got y of 4 as 1 over 12 x raised to the power 4. So that means the solution of the initial value problem by differential transform method is 1 minus 1 over 2 x squared plus 1 over 6 x raised to the power 3 plus 1 over 12 x raised to the power 4. So we terminate the series solution at this point. So far, we have been able to solve a nonlinear initial value problem by the method of differential transform. Thank you.